Hello everyone, welcome back to my YouTube channel. Today again we are going to solve one more daily LeetCode challenge question, and today's date is February 6th, and today LeetCode has given this problem 3634 minimum removals to balance array. First we will go through the question and understand what the question is saying, and then we will go through the constraints, and after that I will walk through the thought process and the solution, and after that we will code. Okay, so this is the outline of this video. Now let's go with the first step, which is to go through the question. Now let's read the question. You are given an integer nums. See, here the thing should be clear to you. Be focused, because I have read the very first sentence incorrectly. So the point here is be focused. Okay, be focused. Then that's it. Just simple. Be focused. Okay. Now let's start fresh once again. Okay, let's go through the question once. You are given an integer array nums and an integer k. An array is considered balanced if the value of its maximum element is at most k times the minimum element. You may remove any number of elements from nums without making it empty. Return the minimum number of elements to remove so that the remaining array is balanced. Note: an array of size 1 is considered balanced as its maximum and minimum are equal and the condition always holds true. Okay. Now the thing here is that they are talking about the balanced array. Okay. Now what is balanced array? An array is balanced if its maximum element is at most k times the minimum element. Okay. And what they are expecting from us is that they have given one array named nums, and without making it empty, we need to remove minimum number of elements to make the remaining array balanced. Okay. Now let us go through one of the examples they have given here. Now observe here that 215. In 215, what is the minimum element? It is 1. What is the maximum element? It is 5. Now observe here that they have given k equals to 2. K equals to 2. Now observe the minimum. Sorry for that. Okay. An array is balanced if the maximum element is at most k times the minimum element. But in this case, if we take a look, 5 is not less than or equals to 1 multiplied by 2. So we need to remove some elements to make it balanced. So see the explanation part they have given. They have removed nums2, which is 5. So if this is not there, so 5 is not there, then what is the minimum? 1. What is the maximum? 2. And here observe that this condition satisfies, so the array is balanced. So here we are taking out one element to make the array balanced, so we need to output the element 1. Similarly, in this example we need to remove 1 and 9 to make the array balanced, and in this one already it is balanced, because maximum element is less than or equals to 4 multiplied by 2, minimum element multiplied by k. Okay, so the output is 0. The main agenda for taking these examples is to get you understand what is balanced array, what do we mean by removal of elements, and the conditions, and These examples make you understand the question a bit more clearly. Okay, now see here the important definition sorry see, here the important point comes. If you look into the constraints, they have given nums dot length is 10 power 5. Now if we write an algorithm which runs in big O of n square, then 10 power 5 square is 10 power 10 with in 10 power 10. So for this case in LeetCode it will throw runtime error. Okay, so we cannot implement big O of n square method. Similarly, nums of 5 is in this range 10 power 9. Okay, 10 power 9, and again k is 10 power 5. Fine. So one thing we need to notice here is that we cannot go through big O of n square. So we may suppose to go to big O of n log n or big O of n. Okay, so this is the whole setting of the question and the examples and the constraints. Now we will go for the thought process. Okay, now let's go through the thought process. Let me take the example which is given by them. It's 1629 and k is 3. So they have given the vector 1629 and k as 3. Now tell me one thing. We need to find the minimum and maximum in an array. Okay, now since we are removing elements, we may remove the small element or we may remove the larger element, and again we need to find the minimum and the maximum element. So one can find minimum and maximum element repeatedly, but is there any way to find minimum and maximum elements, like the first maximum element, second maximum element, first smallest element, second smallest element? Because when we are doing repeatedly, it may end up in taking big O of maybe n square. This is not exact, but it may take up in taking big O of n square, because for finding first largest element, it will take big O of n. Okay, for second largest element it will take big O of n. Similarly, total how many elements are there? N elements are there. So nth largest element it will take big O of n. Total we have, if we compute this, it will be big O of n square. Okay, now it is obvious that we cannot prefer this method. So what is the other way to get smallest and biggest elements? Okay, now this is quite intuition that we will definitely do sorting. And sorting will take n log n time. And apart from n log n, once we have done sorting, we can find any kth largest element or kth smallest element. Okay, so the very first step we will do is we will sort the given nums. Why? For getting the maximum and minimum element in an efficient way. Okay, now next thing. So we have sorted this array. Now what is the array I will get if I sorted that one? It's 1 to 69. It is 1 to 6. Sorry, it's 1 to 69. Okay, now see what we will do is, the thought process here goes like this. We need to remove some elements to make it balanced array. Okay, now what we will go is, suppose I am standing at index and I am assuming that this is my minimum element, not assuming this is the minimum element, and they have given k equals to 3. Okay, now suppose we have an subarray from this one. Okay, basically what I'm saying is, you may have subarray like, oh, just 1, just 1 2, or just 1 6, or just 1 9. Okay, what I'm saying is here, among all these subarrays, the subarray having maximum elements and also balanced, in that one the maximum element should be less than or equals to, maximum element should be less than or equals to k times minimum element. Okay, so here what is the maximum element should be less than or equals to minimum times k element. So maximum should be less than or equals to 3. So we can consider this. So 1 comma 2 is a valid balanced array. This is the only subarray in this one, and this may be the case that we can delete these two elements and we will get 1 2 as balanced array. So how many deletions here? 2, when we consider 1 as the smallest element. Okay, now what happens if we consider 2 as our smallest element? Then maximum should be less than or equals to 2 multiplied by 3, which again turns out to be 6. Now this time we will consider this one as our, sorry, wait, okay, now this one as our balanced array, and we will remove these two elements. Okay, if we consider 2 as, see, if we I will write here, if we consider 1 as the smallest element, how many we need to remove? We need to remove 2. If we consider 2 as the smallest element, we also need to remove 2. Now consider 6 as the smallest. Max should be less than or equals to 6 times 3, which is 18. So if we consider this, once again, sorry, if we consider this, then also we need to remove 2. If we consider 6, then also we need to remove, sorry guys, 2. Now what I'm saying is, carefully observe here. We have one array. Okay, we have one array. Now we will start at index and we will find out the largest subarray with starting index as this one, and this array needs to be balanced, and we are saying that if our smallest element is this one, then we will remove total this have total n elements minus total elements of this array. Okay, total elements of this array. Again we will go for this side and we will again check how many elements needs to be removed. If they are smaller than these elements, then we will update our results with this number of removals, since this is the minimum number compared to the previous one. When we will stop until our subarray is get to the last element, because see, because if we are here, then number of elements to be removed is only this elements. If you move forward, then only this part is longest subarray, and here the number of removals are increasing, but we only want decreasing, we only want less number of removals. So we will stop whenever our subarray ends at the last element. Okay, I think you got the idea. Maybe I have explained in a better way. Okay, fine. We will write the pseudocode for this question. What we will do is we will sort nums. This is the first one. Second one is we will maintain two pointers. One is I, one is j. Will I equals to 0, j equals to 0, and n equals to nums dot size. Now what we will do is while j is less than n, not only j, maybe n also, we can also write j is less than n and I is less than n. In this while loop, what we will write? First things first, we need to get the small element. Small element is I is it's a ith index, and we'll get k multiplied by minimum element. Okay, and the max element should be k multiplied by nums of I. Okay, now what we will do is we will move this array till the first element which is greater than max. We will write one more while loop while k is less than n and nums of it is j, and nums of j is less than max. So it's less than or equals to max. What we will do is we will increase it. Now it may happen that j went through the last. If j equals to n, then we will break. Okay, else what we will do is total number of removals are total length n minus total length of subarray will be j minus I. Okay, and we will maintain one result which we will initialize to int max, and what we will do is we will take minimum of this one. So what it will be is result is equals to minimum of result comma total removals are n minus j minus I. Okay, and we will return result. Yeah, we will return result. I think we don't need this condition, because if j equals to n, then anyway this will take care of that case, and this while loop again won't execute, and it will successfully return the results. Okay, and this is the pseudo code, and if you analyze the time complexity of this code, for sorting it's big O of n log n, and we are traversing through the array once, which is big O of n. So total time complexity is big O of n log n plus big O of n, which is big O of n log n. And if we talk about space complexity, we are not using any external space, any extra space, so the space complexity is big O of 1. Whole code. Now first things first, what we will do is we will sort the nums, which we can do is nums dot begin, nums dot end. After that we need to have the size of the nums, nums dot size. After that we will go through the int. We will define two more variables, int I as 0, int result as maybe let's have upper bound by n, and it's fine. For int I equals to 0, I is less than n, and do I plus plus. Actually it is not I here, it is j. Okay, now we need to take here long well, because our nums of k is 10 power 9 I think, so we need to take long well based on the constraints. We will force our this nums of I times k to be long, and we will find the balanced subarray while I less than n, and nums of I less than or equals to well. Just simply do I plus plus. Maybe I think here I have interchanged the I and j in the context where I have used I and j before in the notes. It's fine. Result equals to minimum of result comma n minus I minus j, and I think that's it, and we will return result. Now let's run the code. What is error here? Heap buffer overflow 1 ll times, sorry bro, this is nums of j. I think this time it should work here. I will submit the code and see the results. Fine, that's cool. I have checked this question. We cannot do more better than n log n. Okay, what I'm saying is we cannot do in big O of n. So maybe don't focus on this area. It's fine. Even if you haven't got maybe this will be simple, but it's fine. Maybe in my code there may be too many comparisons, that's why we have ended up here, but that's not an issue. So I think that's it for today, guys. I think I have explained I think I may have explained in somewhat in a more better way. If you guys have any suggestions for me to improve, kindly please post that suggestions in the comment section. I would love to improve myself, and that's it for this video. Thank you. Jai Hind. I will see you in the next one. Bye.